Hello guys, today our topic is about the circle theorem 2, about the tangent and the chord, okay? So let's move into the first part about tangent and chord, okay? So first of all, what is a tangent? Okay, so you can find in this graph, we have a circle, right? And then we have a tangent, you can find it's a horizontal line, right? And the radius from O, we draw like OT, like this, okay? This is OT. So we also find that OT is perpendicular to the horizontal line, right? Okay. And also the horizontal red line has only y-intercept with the circle. That is a point T, okay? That is it. So we can say that the red line across point T is a tangent of a circle, okay? So we can say a tangent is always perpendicular to the radius, and there's only y-intercept with the circle, okay? So maybe here, if you're just moving the red line like this way, you can find it's still a horizontal line, but now it has two intercepts with a circle. So we cannot say that blue line is a tangent of a circle, okay? That is very important, okay? Okay, so to next part about the theorem 6 about the tangent from the external point, okay? So here we have an external point P, and we also have another two tangent A and B, okay? So we can say, like, there's a point beside or outside of the circle. We have two tangents. We can draw it, okay? And then we can say here, the tangent PA is like here's only one intercept A with a circle, and we can say OA is perpendicular to PA, okay? And OB is perpendicular to PB, okay? That is for the tangent from an external point, okay? That is it. So we can also say the PA's length equals to the PB's length, okay? That is for this part, okay? And you can just understanding like here, if you just connected PBCO, so the triangle POA is the same size with triangle POB, okay? There is very important for us to understand about this, okay? And also the kite property for a tangent. Okay, so first we have like OA equals to OB, right? Okay, so here OA equals to OB and PA equals to PB, right? And also for angle OAP and angle OBP, they're also equals to 90 degree, right? That is for tangents property, right? Okay, that's for this. And also we have the kite shape, right? We form like the PAOB, right? So because of the angle AOB plus angle APB equals to 180 degree, right? So maybe here you can say this angle AOB added with this angle APB, their sum together equals to 180 degree, okay? That is for this theorem. Okay, so finally we have the theorem 7, and it is the most difficult series about the alternate segment theorem. Okay, so here, if we first draw a segment, like here, and then we draw a tangent across one point, like here, there's a red line is a tangent, okay? So we find there's an intercept between the red line and the red tangent, okay? So there we can say the angle x, and we can draw any angle from the segment. Okay, so maybe here, like this is another angle in the circle, and this angle also equals to x. Okay, so we can say here, the angle between a tangent and the chord through the point of the contact is equal to the angle in the alternate segment. Okay, that is for the alternate segment theory. Okay. So like here, the theorem 8 is about perpendicular to a chord, okay? Because the circle is a very symmetrical graph. So we can say here, maybe from O to draw a perpendicular line to the like a chord, we can say that is a perpendicular foot right here is H, okay? So we can say H is the midpoint of the chord, okay? Maybe here is AB. So we can say HA equals to HB, they're the same names with each other, okay? Okay, so here is some deliberate practice for you. Okay, so if you want to try on yourself, you can first pause the video and then do it yourself. But if you want to like follow with me, you can keep on going. Okay, so let's move to the first problem. Like here is that P and PB are the two tangents to your circle center O, right? So we can just try to draw the graph. Okay, here because this point is P, this is A, this is B, right? Okay, so this is a central O. So we can say APB equals to 40 degree, right? So we can connect it OA and OB, right? There's a 90 degree, okay. So angle AOB equals to 180 degree minus 40 degree, right? Okay, so here you can read that as 180 degree minus 40 degree equals to 140 degree, right? That is a kite theorem we said before, okay? That is a first problem. And for second problem is that a chord CD is 16 centimeter long, okay? So we can just write the graph. Okay, this is for the circle. And another chord CD, 16 centimeter long, and the radius for the circle is 10 centimeter, okay? Here's 10. So you can start maybe here when you draw a perpendicular line OH to CD, okay, like this. So here the H divided the CD into two parts, right? The two same parts. So each part is about 8. Okay, so CH equals to HD equals to 8. And also you can just calculate the distance from O to H that you see in the Pythagoras theorem, right? The square root 10 squared minus A squared equals to 6. Okay, that is for second problem. And for third problem is that a tangent touches a circle at point T. Okay, we can just try to draw the graph. Tangent touches a circle at the point T, and a chord TA makes an angle of 65 degrees with a tangent. Here it is, right? Here's A, 65 degree, and find the angle TPB, right? So here, angle TPA equals to angle AT, maybe here's L, right? Angle ATL equals to 65 degrees. This is a rules we said before. So this is 65 degree, okay? That is it. And for the first problem is that explain geometrically when a line connecting the center of the circle to an external point P perfectly bisects the angle formed by two tangents from P. Okay, so maybe for this problem, you can try on yourself. You can using the same angle theorem or maybe same triangle theorem. You can find their size is the same and all the part is the same. That they can divide it into two same parts. Okay, so maybe this for today's our lesson. See you next time. Bye.